Good afternoon and welcome everyone to the 3D Lunchbox Series with online resources. I am Christy Ford, Account Executive and your moderator for today. As a reminder, please use full screen mode to optimize your view of today's presentations. Before we go any further, let me introduce the team at Online Resources here with us today. JD Schomburg is our Director of Business Development. He has been with the company for the past 8 years and a part of 3D data collection for a total of 19 years. Kate Jacobs is our Director of Engineering Services. Kate is our resident expert in reverse engineering and GD&T applications. He's been with us for the past 5 years and is a wealth of knowledge. We know your time is valuable, so let's jump right in. JD, why don't you take over here?
Great, thanks, Christy. So we're going to start with just a quick overview today. This is meant to be a high level of inspection, reverse engineering, and the 3D scanner that we're using today. So company overview is where we'll start with online resources, who we are and some of our experience. Creaform, the manufacturer of the scanner we have in front of us. And then we'll go through a little bit of the products that we're using, which is the HandyScan Black Elite, and then the Geomagic Design X from Geomagic, and then Polyworks Inspector from Polyworks. And then we'll do a little bit of a demo and demonstration with the scanner, and Cade will go ahead and walk you through a quick overview of the reverse engineering and the inspection. So a little bit about online resources. We were founded in 1991, and our flagship product was CAD/CAM. But pretty quickly after that, we decided we wanted to really dig into 3D technologies and got into 3D printing and 3D scanning for reverse engineering and inspection that we'll be showing today. We've been a strategic partner, or the highest level partner, with Creaform since 2006. And then in 2017, we dug into the robotics side of things with QPoint Robotics in our AQC, or Automated Quality Control applications. And we'll discuss those a little bit later. So we also have a pretty large customer base. Some of the customers you might recognize are here in front of you. These are mostly automotive, but we also do aerospace and medical and a lot of other industries. Creaform has a few different product lines, but really their strength is handheld scanning systems that are very flexible and accurate, that can be true inspection quality systems. So the first one is the GoScan Spark. That's a structured white light system that has about 1.2 thou accuracy. And then the one we'll be showing today is the HandyScan Black Elite, which has a 0.9 of a thousandth accuracy and all of the ISO certifications that you need for the inspection process. And then if you're going to be using large systems, the MetraScan will be for you. That's a 600 cubic foot volume where it can keep 2.5 thousandths accuracy over that whole volume. So it's really made for those large products. And then our AQC, or Automated Quality Control, we have a custom software that we really dig into the controls of the robot and everything else in the cell, which would be your safety, your handshakings, things like that, that make a unified system across multiple platforms of production or multiple robotic arms. So if you have questions on those, feel free to contact us later, because that dives into some of the details pretty quickly. So now a little bit about Creaform. They really are a 3D innovation leader. And since they've been in business, we've seen for about 14 years, we've seen 30 different product launches, and they really are disruptors and pushing the envelope of technology. In 2013, they were acquired by Imatech, which allowed them to really get funding to dive into that innovation and help them grow into a truly global company with clients in over 85 different countries. So we'll go ahead and move on into the data collection side of the system. So this is the HandyScan Black Elite. I'll be using some of the hand controls on the back. It is a blue laser light system. And you can see that in the camera. On the screen, you'll see green laser lines. These laser lines are telling me whether I'm too close, too far. So too close will be red, too far will be blue, or green, which is the ideal distance for scanning. I'll be scanning this piece at 40 thousandths of an inch, but it can go down to 4 thousandths of an inch. So today I'm going to go ahead and do a merging of the scans where I'll scan one side, I'll add another scan, and then go ahead and combine those two files before I export them for CADE to work with. Now we do have, this is a metal part, it's a die. It does have some shiny areas on it, but the beauty of the Creaform system is we have the ability to adjust settings to pick up a white matte finish, or if we have a black shiny or high chrome finish, we can do that as well. So now that I have my two scans, I'll go ahead and merge these files together. And we'll just allow Creaform to try and fit those together. It did. We'll go ahead and merge that file. And we will see a full scan that then we can go ahead and export just by file export and send over to CADE to show you the reverse engineering and inspection side of things.
Thank you, JD. Just a reminder, if you have any questions, go ahead and type those in as they come to you, and we can discuss those after CADE's presentation. CADE is going to dive into Geomagic Design X reverse engineering software and Polyworks inspection and quality control software. CADE?
Thank you, Christy. Thank you, JD. Like Christy had mentioned, my name is Cade. I run the service department here at Online Resources. Today I'm going to be showing you a couple of use cases for the scan data that JD had captured in the previous exercise, one of which is reverse engineering inside of Design X, and the other is QC and inspection inside of Polyworks. So everyone should be able to see my screen now. What we have on the screen here is Geomagic Design X. The scan that JD just sent to me is centered on the screen now in blue. So what this software is for creating CAD models using scan data as a reference. So what we're going to be doing is we're going to be building a CAD model around this scan, and then we're going to be comparing that CAD model back to the scan to make sure that it's within an acceptable tolerance and ready for manufacturing process. So the first step is to create the forming surface of the die, which I've done here. So you can see that with the scan data hidden, we have a zero thickness surface on the forming surface of the die. And we can compare this surface back to the die using our accuracy analyzer to make sure it's within a tolerance that we're happy with. You can adjust this as well. Happy with that. The next thing we can do is build the rest of the model. So I'm going to go through, and again, JD mentioned we're running through this very quickly, just a high-level overview. So the next step is to create a sketch at the bottom of the part with our hole locations and the overall length and width of the die that we can use to extrude the entire surface or the entire shape. And I'll perform that extrusion now. And again, during this entire process, we're always able to refer back to our accuracy analyzer and be sure that the model that we're creating is within an acceptable tolerance relative to the scan data. So I'll then perform several other extrusions, sketches, cuts, etc. You can see I've cut the top of the die here, cutting out several of these windows, moving forward to cut some of these other features here. And at the end, we are left with a part that looks something like this. So we have a CAD model of the scan that was built using the scan data as a reference. I can then turn on my accuracy analyzer, like I mentioned before, and check that to make sure that my part is within the tolerance that I'm allowing. So you can see in a couple of areas, we have some areas that are showing out of tolerance. This is indicating that perhaps I still have a feature in that location that needs to be modeled, or it could be that the die has some wear on it, perhaps that in the modeling process, I'm choosing to ignore and create a model to design into. So once the model is complete, I can then send it to a manufacturing process of my choosing, whether I'm machining a new die or if this is a molded plastic part of some sort, I can create a mold using this CAD model, etc. So that is the first use case of the scans. The next use case is for QC and inspection purposes using Polyworks. And I'll open that software here now. So here we have the Polyworks software by InnovMetric, and you can see that we have our scan data on the screen here. We also have our nominal CAD model here in the same location. Now, the scans do not come in at the same location automatically. They come in and they look something like this. They're kind of floating out here in space. So the first step in an inspection process normally is to perform some sort of quick alignment, maybe a best fit, to get the scan in the proper location. So I'll activate that now. Then I've gone through and, per the print's request, extracted some datums, a datum plane A at the bottom, datum plane B on the side of the die, and a datum plane C on the end of the die that I can use for an alignment and measure this part as requested by the drawings, the prints. So go ahead and activate that datum reference frame alignment here. And now I can perform some measurements of my choosing. So I have pre-measured some things here. I'll go ahead and go into the view which shows those. So you can see I have an overall height dimension, which is being tolerant to 0.005 of an inch and is deviating slightly. You see all these dimensions are passing. The ramp angle and the pocket width here. I've also performed a surface profile measurement of the forming surface of the die, which is shown in this view here. And as you can see, that surface profile measurement is failing. We have a tolerance of 0.005 of an inch, and it's deviating by about 41 thousandths. But this does not in and of itself describe how or why the part may be failing. So I've also added some of these annotations here indicating that there's perhaps some material buildup or some wear on the die through use, and that is causing our surface profile to fail. So once we've performed all the measurements that we wish to see inside of Polyworks, we can then output a report. So I'll go ahead and show you that now. You can see our first page is a nice clean title page here with our model centered. Then we have all of our linear dimensions. And then we have our GD&T page showing our surface profile callout. And that's ready for a PDF export to send to the customer for review. Thank you very much for listening.
Thank you, Cade. This is our showcase today. We would love to hear what questions you might have about the scanners and how this technology can benefit your environment. Go ahead and type those in now. While you're doing that, JD is going to share a little bit about our experience with a client, one of ours you might know, Indycar and NHRA. JD?
Great, thanks Christy, thanks Cade. So a little bit about Indycar, these are, and NHRA, these are some of the customers we are allowed to share and have some marketing partnerships with. So in 2014, we partnered with Indycar really to come alongside and assist them in the, when both Honda and Chevy brought on the aerodynamic kits, and they really didn't have enough technology to collect the amount of data they needed for a proper inspection. So their current inspection process was about 150 points of inspection over about 10-15 minutes. And we were able to parallel that inspection process and give them about 50 million points of inspection in under 10 minutes with 0.005 of an inch accuracy from the front wing to the rear wing. So that really allowed them and drove the power to push their technologies forward. And it was also a really cool experience for us. And then we partnered with NHRA. Now, NHRA was not so much the aerodynamic side of things, but really the componentry in the engine. So they have a lot of different engines, heads, blocks, all these different components that go into it, where the governing body needed to manage that kind of information and make sure that they were safe. So we partnered with them and helped them scan every single part that came in to get homologated or justified by the governing body, and gave them archiving capabilities, traceability, and we were able to do it in 1.2 thou accuracies, as well as there was one time where the forward body that you see, we were able to scan that whole component shell to see how it would fit on the structure and suspension. And so that was also one of the needs they had And we were able to keep about 0.005 of an inch accuracy, maybe over about 28 feet. So that was a very cool experience there. So that's a little bit about the two partners that we have in racing and how we help them.
Awesome, thank you, JD. So we do have a couple of questions coming in. Our first one is, how do we use this technology to dial in our process to minimize waste?
That's a great question. It does depend on kind of what process you're using a lot of times. Do they, or could you ask what kind of process that is?
Give me just a second. It looks like they said for rotational mold application.
Okay, so a roto mold application. We have done a few of these, and the experience we've had with it, really dialing in the manufacturing process, is looking at wear and tear on the mold. So similar to what we've done here with this, looking at the inspection side of it, you could scan maybe every 1,000, 10,000, 100,000 rotations or shots or whatever the terminology is for your process, and start to develop a trend analysis to see where does our wear and tear happen at a point where we need to be concerned to rework this because our part is not in spec. And that's probably the biggest application that wouldn't be either before you, like in the engineering design phase or in the post-production phase.
Great, thank you. I hope that answered that question for them. If not, we will definitely be in touch. Okay, second question here. How would you use this kind of technology within the manufacturing environment, or is it all pre and post production?
Yeah, that's a great question as well. Similar to the one we just had. So a lot of times what we saw, or what we have seen today, is the reverse engineering side of things, which would be really in the pre-production. So creating your product, maybe you have one that you're trying to fit in. Post-production would be that quality control in the clean room environment. So on the floor, it's really becoming a wide range of things, whether it's automated quality control, the AQC market, where you're inline scanning to make sure things are done well, or this trend analysis that we talked about for the rotomold application, or sometimes just, man, we had this part break and we don't know how to get our machine back up and running. You can take the scanner in, either inspect or reverse engineer the part that you need and get yourself up and running again.
Great, thank you. Okay, we have a couple more questions here. We have used scanning a few years ago and it failed because the parts were dark and shiny. Where are the scanner's limitations now?
Yeah, good question. So a lot of traditional technologies really were affected by the surface quality or the color of the product. And so Creaform really developed this system. So if we have a black shiny object that's traditionally very difficult to collect, or a chrome object that's very difficult to collect, we can just have a one button click where we turn it up and pick up that surface. Same thing if we have a white matte finish or a gray matte finish, then we can turn that down and collect the part, no problem. So Creaform really has pushed that boundary and allowed us to collect any surface quality.
Awesome. All right, let's see, we've got a couple more here. Quick question, we use SolidWorks. Can we get 3D models into it?
Yes, what Kate showed you today, the model from the reverse engineering side in Design X, that can be exported as a Parasolid or any other kind of file format, IGES-step. We can also do what's called a smart tree transfer, where we actually export it and it builds a live history tree that can be edited downstream in SolidWorks. So you can have one person reverse engineering and that'll be plugged in, and SolidWorks will allow you to edit those features as long as those processes used transfer properly to that software. And that's SolidWorks, Creo, Inventor, you kind of name your CAD package. So yeah, these systems are actually made to really drive the SolidWorks and the innovation in those.
That's good news. All right, last question it looks like. I noticed you scanned a small part. We do have very large parts. Can this scanner do that, and how long does it take?
Yeah, again, a great question. This scanner can do large parts. I give the analogy of a football. If it's smaller than that, then we might use a scanning system. If it's in between a football and a car door, the HandyScan is really the most efficient system for that. If it's larger than a car door, so you're talking a full car, airplane, train, you name it, then we can go into the Metroscan or a photogrammetry shoot or some even long-range scanners that are made for buildings. So the scanner that we've seen today, its most efficient zone is around that football to car door size. It can go larger or smaller, but that's really dependent on the resolution and accuracy needs that come up with each individual product.
Thank you. That is all the questions we have here today. If you have a question and it did not get answered, please let us know. We will try to be in touch with everyone in the next couple of days. Thank you all for joining us over lunch for this first webinar in the 3D Lunchbox series. Thank you, JD and Cade, for your expertise and presentations today. We look forward to seeing you next time for the second 3D Lunchbox series, where we will showcase a bird's eye view of comparative analysis with inspection software. As always, if you have additional questions or needs, you can call our experts at 765-482-9700 or contact us via email at support@onlineresourcesinc.com. Thank you again and have a great afternoon.